Hello, in this lesson, we're going to talk about piecewise function. Piecewise function, okay? Piecewise function, okay, plural. So we're going to talk about some very useful piecewise functions in this section. First of all, it has to be function, right? So what is the definition of function? Function, so let's recall the definition of function. A function is a rule, right? That assigns each element in a set of A exactly one element in a set of B. Each element in a set of A exactly one element in a set of B, right? In particular, EX exactly one element, right? So in particular, for each element, we're going to give a name, right? So that element, we can call it X, as it's always been doing called. And of course, you can use different names. Exactly one element in a set of B, which is called f of X. So we're pretty familiar with this definition, but here, when we talk about piecewise function, and they are still functions, they're still functions, okay? And now, of course, we know there's another version of it, right? A function is a rule that assigns each element in the domain, right? This rule determines a domain. So in the set of A, in domain, exactly one element in the range. Each rule or function, each rule as a function, it has its own specific domain and range, which we have discussed plenty of them. But now, what is a piecewise function? Well, obviously we have pieces, right? And these pieces are following different rules. And one of the functions we have actually talked about was this one, f of X equals to the absolute value of X. Okay, this is actually one of the most useful piecewise functions that you're going to use a lot in calculus, especially calculus 1, and of course you also use it in calculus 2. Now let's recall this. Let's talk about what we know about this function, right? So we're going to use this as example number 1. According to this rule of the function, right? So we understand that according to this rule, right? This rule said I'm going to take an input, right? I'm going to take the input, and this input could be positive number, could be negative number, could be 0. And we take this function, we take the input, and then according to this rule, and we're going to take the absolute value of this input and produces an output. That output, of course, is absolute value of X. Okay, we already know its domain and range. And for this particular rule, and we have talked about that first by observing points, right? By observing points. We have done some plotting of points. Okay, so let's do this again. Okay, the reason we do this again, because this is a very, very important function. Input, okay, input, X, and output, of course, the absolute value of X. Okay, or you can just use this notation. And the input output as a pair. Okay, input, comma, output as a pair. So if we look at some numbers, right? -2, -1, 0, 1, 2, right? And we plug in the numbers in the function. Whoops. Right, we plug in the numbers in the function. And we got some interesting phenomena to observe. So if the input is -2, the absolute value of -2 is a +2. So the absolute value of a negative number is the opposite of the input. Okay, the absolute value of a negative number is the opposite of the input. So the input is -2, the output is the opposite of the input. If the input is -1, the absolute value of -1 is going to be the opposite of -1. So the input, output. When the input is 0, the absolute value of 0 is 0. And input output, when input is 0, the output is the same as the input. When input is 1, the output is absolute value of 1, sorry, and it's equals to 1. So when the input is positive, the output is the same as the input. Okay, so input is 1, output is 1. When input is 2, output is the absolute value of 2. Output 2 is the same as the input when the input is positive. So now what we have observed, okay, we mentioned this earlier, that the absolute value of a non-negative number, a non-negative number include 0, okay, 0 positive, okay, these are non-negative numbers. The absolute value of a non-negative number is the same as the number, okay. This is also say that when the input for this function, okay, which has a rule like this, the input for the non-negative number, if the input is non-negative number, the output will be the same. And the absolute value of a negative number is the opposite, is its opposite. Right? So if the input is negative, the output is going to be the opposite of the negative number. All right, so we have talked about that before. And these two sentences will lead us to the other form of this function, which is right here. Which is right here, right? The absolute value of non-negative number is the same as a number. The absolute value of a negative number is its opposite. And we certainly had the graph of it, right? We certainly had the graph of it. And now I just bring back the graph. And of course, we can put the points in place. Okay, so let's put the points in place, right? -2, 2. Make it a red dot, right? So -1, 1. 0, 0. 1, 1, 2, 2. Okay, so this is the picture we have done before. And you can see that this function actually is made of 2 pieces, For input equals to 0 or positive, we have a piece here. Okay, so this piece. And for input equals to negative number, and we have another piece. So this is actually a piecewise function. Piecewise function. Okay, so this is a typical piecewise function, and you get to use it quite a lot in calculus 1, and also in calculus 2 in various occasions. So next, I'm gonna show you another example of piecewise function so we can have a better understanding of it. So before we look at the graph, okay, this function, of course, I put it in your homework. Okay, actually, all of these, you see them in the homework. Okay, so before I let you see the whole graph, of course, you already saw it. I like to explain to you the meaning of it. The meaning of it. Okay, the meaning here is basically saying if the input is less than -1, and how many numbers are there for input to be less than -1? A lot, right? So if we set up a table, right? So we're going to use this table, right? Input, output. So the creation of a graph is going to be following the rule of this function. So if I pick a number that's less than -1, say I'm going to pick -3, right? The input is -3, so I check all these 3 conditions, and certainly -3 as an input is satisfy this condition. So the output is going to be 1. Sorry, 1. So then now input is -3, the output is 1. If I pick input equals -2, the output is also 1 because -2 is also less than -1. So this rule, okay, tell us that the output is always 1 as long as the condition is satisfied. If this condition is not satisfied, then we will have to check, we cannot use this output. Now, what if the input is -1? When the input is -1, we actually cannot use this output. Output equals 1. So we have to use this condition because input equals to -1. And this second line has, if x is larger than or equals to -1. And so the output is 2. So for input -1, the output is 2. Oh, sorry, I forgot to fill this up. For -2, the output is 1. Okay, so what I'm going to do is that I'm going to make some connections. I'm going to make a rectangular system to plot the points so you can see what's going on. Okay, so you can see what's going on. Okay, before you see the final picture. Even though you saw the final picture, but I still want you to see this process. Okay, I still want you to see this process. All right, so now this function we have, I'm going to make some adjustment for the scale, for the view, right? So I'm going to have -5 here. So maybe here is just -2 and 5. Okay, that should be proper. Okay, so we already have 3 points, right? For -3, the input is input -3, the output is 1. Our input -2, the output is 1. Oops. What have I done? Oh, I need to change it to point. Change it to points. So we get 2 points, right? So if input, if we keep going, say if I'm going to put more rows in there, right? If I input is -4, the output is also 1 because the first condition, right? The first row is satisfied. So I will have another point. So you can see, could I choose fractions, decimals? Of course you can. Okay, we can choose those points as well. So we get these We get these points. We get these points. All right. And then when x equals to -1 for that input, the output is +2. So this point is going to be right there. So there's a change of rule, okay? So now within this interval between -1 to 1, not including 1, we can plot a bunch of points. We can plot a bunch of points, okay? So if the input is a -0.5, right? And the output will be 2 because -0.5 is larger than -1 and smaller than 1. Okay, so that's going to be 2. So we have another point, which is -0.5 and 2. Okay, input output. So if I put this point on the graph, and right there, we get another point, right? So what if I pick input 0? Then we check the condition, right? So I'm going to put this condition right here so we can see them all at the same time. So if, yeah, maybe I put it in the front. That look better? Yes, that will look better. Okay, so if I put another input, okay, I'm going to put more inputs. Okay, I'm going to put a number of inputs. For input 0, 0 is between -1 and 1, right? The output is also 2. So we get another point, which is 0,2. And that point certainly has a place on the graph. There. Okay. Now, what if I choose 0.5, half? Choose a half, positive half. What will be the output? Well, positive half satisfies that condition. And therefore, the output is going to be 2. So we get another point, which is 0.5, 2, right? So input output. So you can see we get another point. But what if we pick +1? If I pick a +1, what will happen? We can no longer use this rule, but we cannot use this rule either because equals to 1, that condition is satisfied here. So when input equals to 1, the output is going to be 3. So input 1, output 3. So we're going to put this point on the dot, on the graph. Put this point on the graph. Okay, right there. Okay, now if we keep going, we can do 2. If x equals to 2, the input is larger than 1. So therefore, the output is going to be 3. You can see piecewise function really is giving rules of function on different intervals. Okay, so this piece is 2, 3. When input is 2, output is 3. So now I'm going to put that point on the graph. Okay, how about for 3, right? We can keep going, right? Or even 2.5, right? So just pick 3. The 3 is larger than 1, therefore the output is going to be 3. So that's how we make the graph. That's how we make the graph. And you can see in both directions, so we're going to have these lines, and these lines. Okay, so now we're going to connect the dots. we're going to connect the dots. Okay, so how are we going to connect the dots? So here's how we're going to connect the dots. Right there. Oh, doesn't do it. It doesn't do it. So never mind. Okay. It doesn't do it. Okay, it doesn't do it. So the software is a little bit confused. Okay, so what I will do is that I'm going to put these points. I'm going to put these points in the picture I pre-prepared. Okay, come on up. Come on up. Oops. Okay, so in this picture, I'm going to put the points in place. Okay, so you get to see this again. You get to see this again. So -4. Okay, so we're going to add the point, and that's going to be a red dot. So we're going to add these one by one. -3, 1. Okay, add another one. -2, 1. So I'm just adding these points, right? One by one. We just plotted. And the next one is -1 of 2, right? Because now we're for +1. So we're just doing these points one by one. Okay, -1, 2. And the next one would be -½ 2. Zero, 2. Okay, so let's take a look what we got, right? So we got those dots. Now we have connected the dots. So 0, 2, and now we have a few more points to go with, right? Half, right? 2. Okay. So we're going to add items. Half 2. And a few more points. 1, 3, 2, 3, 3, 3, right? And 1, 3. Oops. Okay, so 1, 3, 2, 3, and 3, 3. So we got all of these dots, and we have connected the dots. Or connected the dots. But what's interesting about these kind of picture is that you can see that at the point of a -1 at the borders of each interval, right? At the borders of this interval, there tends to be some kind of confusion, right? There tends to be some kind of confusion. To clarify that confusion, what do we do here is that at a -1, right? We want to show the reader at -1 and 1. This point is going to be, whoops, hold on. Okay, at a -1, -1, 1, we're going to put a circle right here. We're going to put a circle on here. So what does this mean? This means that when input is -1, the output is not here. So this is a circle, and the output is right here. Okay, so when we read the graph, at input equals to -1, which is at the border of 2 intervals, right? The end of the first interval and the beginning of the next interval. And the rule says if x is larger than or equal to -1, so we're going to pick input 2. So for that reason, we're going to, when we draw the vertical line, hold on, this vertical line is too thick. Okay, so when we draw the vertical line to get our output, so what do you see here? You're going to see, remember the vertical line test, right? For each vertical line, it should cross the curve only no more than once. So when we draw this vertical line, it tells the reader that when input is -2, the output is up here. The output is up here, not here. Okay, this is what you're going to see. That's typical of this kind of situation, okay? And the next piece we're going to work with is about this other borders, right? What is this border? It's between the interval between -1 to 1 and the other one. Oops. Okay, and the other one. And the other one between -1, but between +1, which is at the end of the the interval before and the beginning of the next interval after. So what are we going to do? What we're going to do here is that we're going to do something similar. We're going to do something similar to what we did earlier. So at +1, okay, at +1, right? So if we draw a vertical line at +1, the output should be found on the next line. So this piece, we need to put a circle, just like we put a circle here. Okay, so that's what we're going to do. Okay, so that's 1, 2, that point is 1, 2. It's a point, it's a dot, but we're going to put a circle. We're going to put a circle. So this tells the reader when we draw the vertical line for input equals to 1, okay, this vertical line crosses the entire curve no more than once. It crosses here, and so this is the output. So this point is the output. So for input equals to 1, the output is 2, not 1 here. I'm sorry, its output is 3, sorry. The output is 3, not 2, okay? So this is what is necessary for us when we draw piecewise function. So that's about what I would like to explain. So typically the picture you see here, the circle means that point, the input for that input, the output is not here. The output is somewhere else, okay? Could there be the 2 circles? Of course, it depends on the function. It really depends on the function, but we use circle or dot to make that distinction, And this is the function we have just saw. Okay, so this is the graph of this function. And this function has 3 pieces. So it's called a piecewise function. But this function also have another name. Okay, this function also has another name. Not only is a piecewise function, sometimes it's also called a step function. Step function, so have steps, right? Step 1, step 2, step 3. Okay, so this is also called step function. So you understand that step function is also piecewise functions. Okay, so this is the second example. But before we get to the next one, I would like to ask you a question. So what will be the domain and range for this function? What will be the domain and range of this function? And what will be the range? What will be the domain and what will be the range? Okay, you may like to pause the recording and guess. Okay, so now suppose you've done that, the domain is all real numbers because every real number, okay, is included. Even though we have different rules for different piece of intervals on the horizontal line, but the range, we actually only have 3 numbers. Okay, and to express the range, we use curly brackets, and we only have 3 numbers. So the output is 1 or 2 or 3, the output. So for all the input we can possibly have, the output is 1 or 2 or 3. No other possibilities, no other possible values. Okay, so that's a piecewise function. So let's look at another one. Okay, we look at pieces. And this function, okay, and for this function, we're going to have, this is called example number 3. Okay. The function goes like this. F of x is equals to we have 2 pieces. Or 2 pieces. One piece says if, okay, if x is less than 0. Okay, and the other piece is if x is larger than or equal to 0, right? So for these 2 intervals, the rule of the function are different. One is x plus 2, and the other one is 1 minus x. So you would imagine that we have 2 rules for the function. It looks like all the real numbers are covered, right? So domain is really all real numbers. But the range is to be discussed, right? Because we have 2 different rules. So these kind of rules basically said if x is less than 0, we're going to use this rule. If x is greater than or equal to 0, we're going to use the other rule, okay? So now, to graph this function, you just plot points, okay? You just plot points. So you're going to graph, okay? One way to graph it is that you, for x less than 0, right? For x less than 0, and what is x less than 0? So I'm going to show you, I'm going to get you a rectangular system. Okay, so we have a rectangular system here with a view, right? For this rectangular system, I'm going to set up the frame. Okay, just for now. All right, so that's the rectangular system. I know the domain is all real numbers. For x is less than 0, right? So when we use this rule, obviously this is a line. So you're going to plot points for this rule. For example, I can plot points, right? For let me put the table up here. Let's see if that will help. 3 columns, number of rows. Maybe I put the table down here, right? Well, this software doesn't line things up for me well. But anyway, so let me put, maybe I'll just put it here. The alignment is not, as good as I wished, but we can manage, right? So we're gonna, when we pick point, we're gonna pick points for different rules. Okay, we're gonna pick point for different rules. So input, output, right? Input, output. All right, so to follow this rule, our input has to be less than 0. So we're gonna pick, say, -3, and the output is gonna be x plus 2, right? Input plus 2, and the -3 plus 2, and that's gonna give me -1. So when x equals to, when input is -3, the output is -1. When input equals to -1, what would that be? The output is going to be -1 plus 2. So that's going to be +1. So for input, so for the rest of it, you can also plot points, right? So here you're going to have -1 as input, output is 1. Because this rule says the input is less than 0. So you can certainly pick a point which is very close to 0. So I can pick 0.000, I mean negative, okay? 0.001, for example. And my output will be -0.001. So it's going to give me an output, right? The output is going to be what? It's going to be positive 1.991. Is that right? Oh no, 999, sorry, 999. Okay. So we got another, so we can pick input as close as to 0 as possible, but never is 0 from smaller than 0 side, okay? So as a result, we're gonna get for input equals to -0.001, and the output is 1.999, okay? So these 3 points actually will be sufficient to plot the first rule, because this is just a straight line. So we're going to put these 3 points in place. Okay, so I'm going to put over here. I'm going to add a point. Okay, some of these red dot. Okay. Add another one. Okay, first do 1. Okay, so that's 1 point, right? So that's this point. Okay. Now the question is, what if we put a 0 in there? Because when we have 0, the rule is going to be using this second rule, right? When we use 0, so the output is going to be 1 minus 0. Right? 1 minus 0. So that point is going to be 0, 1. So it's a different rule. Now, how do we show to the reader? Because you can see this point, it's on the vertical line. So it doesn't look very good. So I need to, this is the error that some of the graphing software often produce. So I'm going to remove this point temporarily now. Okay, just to put these 2 points, -3, 1, and -1, 1. Okay, I'm sorry, -3, sorry, -3, -1, and -1, +1, right? -3, -1, -3, -1, and -1, +1. So we have these 2 points. Okay. At 0, right? At 0, our rule is going to be different. It's a 0, 1 because it's going to be the second rule. So when I put this point, you know it's going to be the second rule. Okay, so that's going to be a dot. And that's the actual point. But the question is that when you connect these lines, right, it's going to be connecting, but very close to 0, we have to stop. So we should put a little circle here. We should put a circle here. So this is what I mean. Okay. You know what I'm going to do? I'm going to do 1 more point for the second line. Okay, I'm going to do 1 more point for the second line so we can make that, right? So for the second rule, I'm going to pick x equals to 1. So 1 minus 1 is going to be 0. And so that now I get another point on the second rule. So this is 1, 0. So now I can connect the dots. Okay, I can connect the dots. I can connect the dots. It looks like we're gonna have a line. We're gonna have a line like this, right? We're gonna have a line like this, but not touching the y-axis on this rule, but we're gonna have another line like this. So this is what we're getting. This is what we're getting, okay? But what shall we do with this point that's, we want to tell the reader that it's not including this point, okay? And we should put a circle here. We should put a circle here. So at 0, 2, we should put a circle here. So that will be the complete picture if you graph it by hand, okay? So for that reason, I'm going to put that circle 0, 2 there, but it is a circle. It is a circle. Okay, so now let me remove that. So this is the picture. This is the picture of the graph. Okay, so now I can make it better. I can make it better. Okay, so now that's how you graphed it. That's how we graphed it. Okay, so I'm going to make it a better, and so I will have to do a little. I have to work with the software. I have to work with the software. Okay, so the software will produce that picture, but I have to put some other dots in place. Okay, you can see it gets that shape, right? It gets that shape. But we have to put the dot, we have to put the circles there. We have to put the circles there. Okay, so that circle, so let me make some adjustment to the graph. Okay, and I would need a circle. Okay, so this is a complete picture of this piecewise function. If we want to put the points, right? If we want to put the points that we did there, but we did before, right? If we want to do the points we did before, we can, you know, I do want to show you that. I do want to show you that. Right, so this is the result of connecting the dots. So what we did earlier, we have done is something like that, right? So this is the piecewise function. In your calculus class, you're going to be studying these kind of piecewise functions. Okay. Now, as I said earlier, I wish to put those points that we plotted in the picture. That's not a problem. We can certainly do that, right? We can certainly do that. We just put those points in the graph. We just do the points in the graph. This one I wouldn't put there even though we did it. I just demonstrate to you that the input can be as close to 0 as possible from smaller than 0. Okay, but this software cannot handle it because it will get too close to the y-axis. So what I'm going to do is I'm going to put these points on the graph. Okay, I'm going to put this point on the graph. And those are red dots. Okay, so that's 1. And there's -1, +1. -1, +1. And then 1 more and 2 more points, right? 0, 1 and 1, 0. So these are the points we plotted. Oh, no, sorry, these other ones should not be circle. My bad. So that's a dot. That's a circle, but this is a dot. Okay. And that's a dot. My bad. And that's a dot. one more, and that should be a dot. There you go. Okay, so for you to graph it, you will graph these points. At the border, which is at a 0, we know we're going to use the other rule. So the other rule's dot is right here. So this is going to be a function because it passes the vertical line test. It passes vertical line test. Okay. Does it pass horizontal line test? No, it doesn't. So it doesn't have inverse, right? So now what's the range? What is the range, right? We have found the domain, and what is the range? The range obviously is going to be less than 2. It's going to be less than 2 because from here, from 2, it never reaches 2. Okay, it's always a little bit less than 2. All right, so it's from negative infinity to 2. Okay, so from here all the way down below, okay? So the range of course is a vertical concept, right? So from 2 to positive infinity. 2 to positive infinity. You can also use inequality for the range. So f of x is going to be less than 2. Okay. So let's look at another piecewise function. I've chosen these piecewise functions. Most of them from your homework, actually, they are from calculus text. When I was teaching calculus, what I found, a lot of our students actually have a hard time with the graphing of these piecewise functions. So for that reason, I decided to cover that in pre-calculus. So now this is example number 4. Okay, and this function is going to be over here. Okay, I just pick one from your homework. Okay, so f of x equals to, we got 2 pieces. Okay, and these 2 pieces are the absolute value of x here. If x is less than 2. And the next one is square root of x minus 2. So this time I'm going to use the software just to plot it. Okay, and I will explain to you. So if x is greater than equals to 2. Okay, so what I would do is, and I have the software do it, the absolute value of x for less than 2. You know, I think the software actually didn't do the right job. Okay, because for less than 2, right? For less than 2, the picture doesn't seem right. Too bad. But we're going to do it over. Okay? Okay. We cannot blindly just trust any software. We really have to know what we are expecting. Okay? The reason I think it's wrong, the previous picture is wrong, is because they see for x less than -2, right? If we plot some points for x less than -2, we shall get some, we shall get some points. Okay, so then let me show you why I think it's wrong. Okay, so I'm going to make a table for x less than 2. Okay, so that means I'm going to pick input, right? We need one more column. Output, right? The output is going to be absolute value of x, because for x is less than 2, f of x is equals to the absolute value of x. Okay, so our points is going to be, you know, input output. Input output. Okay, so because x less than 2, it could include any negative number, 0 and positive 2, not including 2. So if I pick, say I pick -2, right? I pick -1 and I pick 0, right? And a +1, right? If I pick all of these points, I should certainly follow the rule of absolute value. Say I can even pick 1.5, right? So under these rules, when x is less than 2, and I will be applied the first rule, and I shall get a bunch of points. Okay, so for input a -2, the absolute value of -2 is a +2. And so it's basically the picture of absolute value of x only up to 2, not including 2. Okay, so here -1, which equals to 1, and 0, right? So here's -1. So here's 0. And so here's 1, 1, and the output is 1. So we get a bunch of points like that. We get a bunch of points like that. And the input can be very close to 2, but not equal to 2 from smaller than 2. So what I meant is that our input could be approaching 2, right? So our input can be approaching 2 from smaller than 2. Okay, so that's the notation. Let me write it down so you can see it. So x can be getting as close to 2, but less than 2, infinitely close to 2 and less than 2. So we get these points. Okay, input a -2, 2, and input a -1, +1 is the output, 0, 0, 1, 1, and 1.5, comma 1.5. Okay, so now if I set up a rectangular system, and I will be plotting these points. Okay, I'll be plotting these points. What I end up, okay, so I'm going to get some points. There, whoops, and less than 2, right? So on this piece, right, and it's basically absolute value of x, right? Basically absolute value of x. So I'm going to plot that function. Right here. And there we go. So we should have this picture. Okay, we should have this picture. How about beyond 2? Beyond 2 is going to be the different rule. It's going to be the other rule. Okay, it's square root of x minus 2. And at 2 is going to be, the output is going to be 0. So on this piece, okay, on this piece, that scale is about similar. Yes, on this piece, that's a picture we're getting, okay, from negative infinity to up to 2. And over here, we're going to put a little circle. We're going to put a little circle. The circle is going to be 2, 2 with a little circle. And this circle means that when x equals to 2, this rule of the function does not apply. This rule of the function doesn't apply. So we have graphed half of the function, which is for x less than 2. How about x is greater than or equals to 2, which is the other piece, right? So we're going to graph the other piece. So now we're graphing the other piece. And this other piece is when x is greater than or equals to 2. Okay, so we're going to set up a rectangular system. We're going to set up a rectangular system. Let's see, what do we do? Ideally, we can set up the same system, but unfortunately, this software doesn't work very well. So I'm going to figure out a way to do it. But for now, we're going to just graph for x larger than 2. Okay, so we can do that. And then we're going to compose it together. Okay. Y equals to 0. So we're going to graph the picture. Okay, so this is x input from 2 to say, I can just to 5. So negative 5 to 5. So we're going to graph the other piece, but from 2. Okay, you can see this point is x equals to 2. All right, so for x equals to 2, we're going to plot a couple points. Right, according to this rule. So what would that be? So I'm going to make a table. So x, right? And the rule is the square root of x minus 2. And I need another column. Okay, so input, output. Right there. So if then this x start from 2. Okay, maybe if x equals to 2, root 2 minus 2 is going to be 0. Root 0 is 0. So that point is going to be 2, 0. 2, 0. So I'm going to put that point in the picture. Like that. Okay. Oh, we want a red dot. There. Where's my red dot? There we go. Okay. If I pick x equals 3 and root 3 minus 2, that's going to give me root 1. Root 1 is 1. So that point is going to be 3, 1. So 3, 1 will be plotted right here. Okay. And what else? The next one, I'm going to choose 6, right? Root 6 minus 2. 6 minus 2. Sorry, root 6 minus 2. Root 6 minus 2 is root 4. Root 4 is 2, right? So for 6, we get 6, 2. So I think that's enough. So we basically get a picture. So I need to extend this view just a little bit. Okay, so this point will have a place. red dot right there, right? So we'll connect the dots. So if we connect the dots, we really just get the picture for root of x minus 2. So you can see why I said the picture we got earlier is wrong. But I know how to get the right picture by the software. So by this time, we get two pieces. We got two pieces, right? So we're going to piece these two together. We're going to piece these two together. So the earlier piece, I'm gonna bring it back to us right here, right? So right here, so these two pieces are going to join together. Okay, these two pieces are going to join together, and I'm going to put it in one picture. To put that in the one picture, I have to do something in order to make this software work. I think this way would probably work. Okay, so essentially you have a picture that this piece, right? And for 2, it gets to be here. So I'm going to show you. I think I can get that done successfully. I think this software has a limited, capacity. So I have to do something about it. Okay, so I'm going to insert a row above. So I'm going to have to work this out. Okay, so for x larger than between 0 and 2, it's going to be x. For otherwise, it's a negative x. Okay, if x is less than 0. Okay, I think this will work. There, yes, it does. Just make it scoot over. Okay, make it scoot over. If you look at the picture, okay, compare with the earlier picture. Okay, so this here, I made some modification to the piecewise function. Hold on. Okay, so you put them next to each other. Right, I'm going to put it next to each other. You can see this is the picture joined together. This is the picture joined together. Very well, I haven't found a good software that's easy to use. But this one, of course, you guys don't need to know how to use this software. You're going to graph it by hand, right? So you can see this the piece, the absolute value piece for x less than 2. And for this other piece from 2 to infinity. So here we need to put this little circle here. We need to put this little circle there. Okay, so we're going to put a little circle. And that circle is, of course, we know what that is. Okay, so 2, 2 is going to be a red circle. There you go. And over here, we're going to put the dot there. Okay, just to tell the reader, yes, we, when input equals to 2, okay, when input equals to 2, the output is 0. So this picture will be complete. I'm going to make the view just a bit wider. And there we go. So that will be the picture. If we want to put the previous dots, in the picture, and we certainly can. Okay, so I would do that. The reason why I want to do that because I want you to reflect on how we have plotted the points. Okay, so this is a table we did for the second piece. Right? And there's another table we did for the first piece. For the first piece, even though we're pretty familiar with graphing these functions, but you really need to understand that, right? And you can put these two pieces together. We can put these two pieces together. Okay, so that's what I'm going to do. Okay, I'm going to put these two pieces, so 4 rows. I'm going to add these 4 rows, right? So now it's just f of x. We have different rules, right? And these 4 rows is going to be, 3 rows is going to be, sorry, is going to be here. Okay, so this piece, right? So this piece is for x less than 2. And that piece is for x is larger than or equals to 2. So using one table, you can construct one table. Okay, I'm going to put a couple points in place. I'm going to put these points in place for the picture. So should we reflect on the process, we're graphing it. Okay, so -2, 2, red dot, right? -1, 1, red dot, and 0, 0, red dot, right? So these are the dots we have placed on the first rule, right? For 1, 1, of course, we also have another dot, which is 1, 1. So what we are saying here is, oh, that should not be the circle. My bad. That should be a dot. Yes, so this piece, right? When we graph this, you follow the rule and you plot these points, and then the other points, right? 2, 0, 3, 1, 6, 2. Okay, so we put these dots in place. We put these 3 dots in place. So 3, 2, that's going to be a red dot. Right, that dot, and there's a 3, 1. Three, 1. So now it's complete. It's a completion of all of our work. So when you graph, when you make the table to plot points, okay, we have to be aware that these points you plotted follow one piece of the rule. Okay, and the other one you plotted follow the other piece of rule. So we have 2 pieces of rule here. And that's what we, that's how we get this picture. That's how we get this picture. Okay. And of course, this is not the only way to do it, but one thing is certain, after you graph the function, you have to make sure it passes a vertical line test. It passes a vertical line test. Okay. For example, sometimes I see people graph like this. Okay, you have 2 functions, right? And we've done this one, this is the correct one. I see a lot of such mistakes. Okay, I already told you this is a mistake, right? I already told you it's a mistake. So what kind of mistake would that be, right? And I saw this when I was teaching calculus. The picture, well, the functions is like this, right? So the student will graph it like this, y equals to 0, right? So I'm going to set up the rectangular system. And this student, whoops, what am I doing here? So why this time it does the right thing? Oh, is it because I was copying and paste? That's really strange. That's really strange. Actually, I didn't know how they come. Wait. Never mind. Okay, so this is a rectangular system we have there. So the student will graph this piece, say, oh, okay, this is absolute value function. So I'm going to graph that piece. The absolute value, right? The absolute value function. Boom, right? We got it. And the other piece is a square root of x minus 2. There, so I can even use a different color. Doesn't matter. And so they present this solution. And of course, this is a mistake, right? This cannot be. Why? Why it cannot be? If you draw a vertical line test, what is statement for vertical line test? You draw vertical line arbitrarily. You draw the vertical line anywhere. You should cross the curve no more than once. And for the second vertical line I drew right in front of you, it crosses the curve twice. Right? Cross the curve twice. So this cannot be a function. So when you do something like this, no, this is wrong. This entire picture is wrong. Okay, you cannot do this. I saw these kind of answers when I was teaching calculus class. So you guys really need to get this. Make sure you get this. Okay, but just out of curiosity, you know, I'm just out of curiosity. So this is a mistake. Okay, so let me show you. This is a mistake. Because I wonder if the software suddenly will do the right thing. Okay, so I'm going to try again. Do you think the software suddenly would do the right thing? It does. It's amazing. So maybe I have done something wrong earlier. Huh. Isn't that nice? Actually, I like it. I like it. Thank God I didn't have to maneuver or break this into 2 pieces, right? There you go. So the software actually would do it. Maybe I didn't do something right. But anyway, so wonderful. So I'm going to keep this picture. So in your calculus class, you just have to put a circle here, a dot here. Okay, so usually that's what you need to do. Okay. You're going to put a circle. You're going to put a circle there, right? You're going to put a dot over here. That's all you need. Okay, the dot, 2, 0, which is a dot. That's it. So in your calculus class, you probably see a picture like this. And then you're going to study its other properties like continuity, limits, and so on and so forth. Okay. And here we try to get you guys to understand how to graph it. Okay. Now, let's do a couple more examples. And these examples actually are, as I said earlier, they are from your calculus text. They're from your calculus text. Okay, so I'm not that creative. So I'm just a copy and paste. Okay, so the next example we like to do is going to be a little bit more interesting. This is example 5. Oh, we haven't talked about domain and range for the one, right? Just make it a domain and range. Okay, domain and range. Okay, before we get to example 5. What is the domain? The domain to this function is actually all real numbers. You can see the entire number line, right? All the numbers are covered, right? Are defined. So negative infinity to positive infinity, no problem. So what is the range? The range you can see is actually from 0 to infinity. Okay, it's from 0 to positive infinity, from 0 to positive infinity. Okay, domain range covered. Now let's look at example number 5. Okay, so this function, which I copy from a calculus text, goes like this. Equals to, there's 3 pieces. There's 3 pieces. Oops, 2 columns, 3 rows. And of course, we're going to have that shape, right? 3 pieces. The first piece is sine x. Oops. Sine x. If x is less than 0. Okay, we know sine x curve, right? 2. If x is between 0 and 3, less than equals to x less than 3. The third piece is x minus 3 squared. If x is larger than or equals to 3. All real numbers is covered, so domain is no question. Domain is no problem. Okay, domain is all real numbers. Negative infinity to positive infinity. There you go. So how the graph, right? There's 3 pieces, right? So at an interval, there's a sign less than 0, you know, between 0 to 3 is constant, right? 2. And this is a parabola. So we can just graph this function. Okay, so I'm going to graph this function to see if they give me the graph. I think it does. There you go. There you go. Okay. So we get the graph. If you have any questions about details of the graph, we can try some points. But the software does pretty well. They gave me the point. But we need to put the circles and dot in place. We need to put in the circles and dot in place. That's important. And obviously, this is a, sorry, I spilled my tea. Sorry about that. Sorry about the noise, okay? So I want you to examine the picture. Obviously, it is a function. So this software seems to have done the job for us, right? Very good. Okay. On this piece is sine, but it doesn't include 0. So at 0, 0, when input is 0, sine 0 is 0. So, but this point is not included in the graph. So we need to put when input is 0, output is 0 on the sine, but that is a point that cannot be on the curve. That point cannot be on the curve. And for x equals to 0, see, for x equal to 0, the output is 2. So we should have a dot on here. Okay, so we should have a dot at 0, 2. 0, 2, and this must be a dot. So these must be reflected on your picture. Okay, I assure you that when you are in calculus class, you're going to be, you know, drawing some of these pictures. Okay, so from 0 to 3. At 3, the second rule does not apply. So this piece, when input is 3, output is 2, cannot be in the picture. So we need to put another circle, okay, which is 3, 2. And that has to be a circle. There. Okay, the last one, which is greater than equals to 3, right? When x equals to 3, we can apply this rule. So on this piece of parabola, we have a dot. So 3, 0. 3, 0, and that should be a dot in red. That's a dot in red. So that's the piecewise function for this function. Okay, so sine piece, so you know what sine is, and the constant, right? Constant between 0 to 3, x minus 3 squared is the other piece, which is a parabola, right? And we have to take care of these dot and circles. That's the most important thing you're going to encounter in calculus. Okay, so that question seemed to be not too hard, right? Not too hard. Let's do another one. Let's do another one. I don't know how much time has passed. Let's do a 2 pieces. Let's do a 2 pieces. Example 6. Okay, and this function is, you know, it's a trig function. So f of x is equals to, you know what, I forgot to talk about domain and range for the previous function. I should do it. Okay, so let's go back there. Sorry about that. Domain and range. Domain and range. Right? What's the domain and range? Domain we already talked, right? Domain is all real numbers. So what's the range? It looks like the range, right? You can, if you can see how low it can go, the entire picture, right? The lowest you get is -1, right? The lowest you can get is -1, right? Which can be achieved by sine. And the rest is going to be, you know, all real numbers from -1 to infinity. Okay, so the range, even though these may not be terribly important, right? Domain is all real numbers, because in your calculus class, you'll be actually discussing what is going to be, what's happening at those dots and circles. Domain and range is not super duper important. Okay, so it's from -1 to positive infinity. So that's the range for that, for this function. Okay, sorry about that. All right, so example number 4, we're going to do 2 pieces, right? So the first piece is sine x, and this piece is if x is less than pi over 4. Pi over 4. Okay, and cosine x if x is larger than or equal to pi over 4. Okay, we are pretty familiar with sine function, cosine function. So let's see if this picture, if the software will do the right thing for me. It's going pretty slowly. It goes too slow. That makes me nervous. It makes me nervous. How about you guys try to graph it yourself? Okay, while we're waiting for this to graph it. I don't know what's the reason. Okay, is it because the internet seems to be fine? Okay, I'm gonna have a sip of tea. All right. The program is not very happy. Okay, so how about we stop here and we come back to it. And meanwhile, you guys practice on this. And I'll see you on the next lesson. We're gonna still do piecewise function on the next lesson. Okay, thank you for watching.